Welcome back to the CCNA Cisco NetAcad Switching, Routing and Wireless Essentials lecture series. If you are interested in the previous lectures, I will leave a link in the description for the playlist. Today, we will be focusing on the module number 3, which is the VLANs or Virtual Local Area Networks. In this lecture, we will explain how network protocols enable devices to access local and remote network resources. We will cover an overview of VLANs, VLANs in a multi-switch environment, how we can configure VLAN on a Cisco device, VLAN Trunks, and dynamic trunking protocols. Just like some of my previous lectures, this lecture is a little bit theory heavy and also lab heavy. Therefore, there may be some lab documentation that we cover in this lecture that I will post with separate videos onto my YouTube channel. Overview of VLANs. So what is the definition of VLAN, or what are the definitions of VLANs? So VLANs are logical connections with other similar devices. Placing devices into various VLANs have the following characteristics. It provides segmentation of various groups of devices on the same switches. So in other words, you could have the exact same switch that is dividing different departments such as IT, human resources, and sales. And VLANs provide organization that is more manageable. So VLAN can be used for organizing your network that can be easily managed. And how it does that is by breaking up broadcast, multicast, and unicast into separate segments by isolating them using these individual VLANs. In other words, the VLANs can break up the broadcast, multicast, and unicast domains. And each VLAN will have its own unique range of IP addresses, hence breaking up your network and causing the network to have smaller broadcast domains. So in other words, the VLANs will allow you to not only segment your networks into various groups such as IT, HR, and sales, it also enable by doing that, breaking the broadcast domain into smaller segments. So what are the benefits of a VLAN design? So there are a couple of benefits by using a VLAN design on your network. It breaks down the broadcast domain into a smaller areas, as I mentioned previously. By dividing the LAN, it reduces the number of broadcast domains. Hence, it reduces the congestion, the broadcast congestion of your network. It improves security. So only the users in the same VLAN can communicate together. It improves IT efficiency. So the VLANs can group devices with similar requirements, such as faculty versus students versus guest networks. So you can use the VLAN to separate those networks. It reduces cost. So one switch can support multiple groups of VLANs. Hence, you don't need multiple switches to break up your broadcast domain. And it improves performance because smaller broadcast domains reduces traffic, improving bandwidth within your network. And it makes easier or simpler for managing the system. So similar groups will need similar applications and other network resources. So for example, if you have an IT department and if you have a faculty and a student department networks, so what's going to happen is IT may require more resources compared to students and guests, and therefore you can break them down through VLANs and allocate those resources according to those needs of separate departments through those VLANs. And another key important thing here it is highlighted is the security. So you can also apply security policies using firewall applications and other applications to specific segments of the VLAN. An example would be if this guest network is considered as insecure, you can apply additional policies onto VLAN 30 as opposed to security policies that have been applied to faculty and students. So those are some of the brief overview of the benefits of using VLANs. So what are the types of VLANs? So there are some default VLANs available already on your Cisco devices. One of them is the VLAN 1, which is the default VLAN, and it is the native VLAN and the default management VLAN, and those VLANs, so the VLAN 1 cannot be deleted or renamed. Please note, while we cannot delete the VLAN 1 on Cisco, we'll recommend that assign these default features to other VLANs. So what that basically means is, even though Cisco devices comes with VLAN 1 already built in and enabled, often enabled, sometimes still enabled but inactive, is like, you know, the VLAN 1 will have that default VLAN and native VLAN and management VLAN attached to it. However, Cisco and most security professionals recommend that you assign those VLANs to other VLANs such as VLAN 99 or random VLAN like VLAN 50. And you can actually shut off that VLAN 1 even though it cannot be deleted. This can increase your security because a threat actor who knows that all Cisco devices comes with VLAN 1 may try to use that VLAN 1 to gain access to your network. So even though the default is set to VLAN 1 for the native VLAN, management and the default VLAN, you can change that to other VLANs, and that is the recommended procedure for implementing the Cisco switches and routers. So when it comes to the types of VLAN, there are separate VLANs we can use for separate network traffic. So data VLANs are dedicated to user-generated traffic, such as email or web traffic. VLAN 1 is the default data VLAN because all interfaces are assigned to this VLAN. So the VLAN 1 is typically always on VLAN in Cisco devices, and anything that is untagged or any untagged traffic typically go through that default VLAN. And I will describe what are the untagged and tagged traffic later in this lecture. Native VLAN, this is used for trunk links only, and all frames that are tagged on a 802.1q or also known as 1q trunk link, except for those on the native VLAN. So the native VLANs are all frames that are tagged on the 802.1q trunk link, except for those on the native VLAN. Management VLAN is used for SSH and Telnet VTY line traffic and should not be carried with end user traffic. So the management VLAN should not be used for any end user traffic. It should be used for SSH and Telnet access. And typically the VLAN that is the SVI for the layer 2 switch is associated with the management VLAN. And if you would like to know what the SVI management link look like and how it can be set up, you can watch my previous lecture, and I will also leave a link and information in the description of this video. Another type of VLAN would be the voice VLANs. So a separate VLAN is required because voice traffic requires assured bandwidth, high quality of service priority, ability to avoid congestion, and delay less than 150 milliseconds from source to the destination. So you can set up a separate VLAN for your voice that will satisfy these needs of a voice VLAN. And again, I will go through separate lecture series on VoIP and voice VLAN systems on a separate video. But for now, remember that the voice VLAN is a very useful tool that you can create to give those priorities for the voice traffic. So the entire network must be designed to support voice instead of like a part of the network is designed to support voice. So in other words, it's what we call the bottleneck effect. So sometimes you might go to the field and your network administrator or network technician may tell you that the network is designed for voice, but when you look at the system, only part of the network, let's say this switch is configured to handle voice, but not these ones, then it's going to create a trunking effect, basically, the bottleneck effect. What bottleneck effect does is basically, because this is set up for voice, but this is not, the voice traffic may not go through properly because, even though it is going fast in here and given all the QoS priority, and whether because this QoS priority is not set up in the other levels, it just basically go back into the same as any other traffic. So the switch port configured to support voice traffic has to make sure the port sends CDP frames to provide information used by the IP phone, and port forwards frames associated with that particular VLAN assigned to that voice traffic, in this case VLAN 150. And the VLAN 150 is used for voice, has to be always assigned on those switches and routers with priority for that voice traffic. Otherwise, this VoIP system will not work as expected. This is an overview of VLAN's concepts that I put together in this lecture. This is an additional slide that is not available on your default Cisco slide set, because I found that some of the information contained within this lecture may not be very clear to students and people who are new to network engineering and technology. So what you need to understand for VLANs for this course as well as for your career is that VLANs are used to break up broadcast domain and apply security and QoS policies. So you can use VLANs to break up broadcast domains, like instead of having large number of end users and devices connect to one single network, you can use VLANs to break those network into smaller broadcast domains. For example, IT department having a separate VLAN versus the management department versus the accounting department versus the students and the guest. And you can also use the VLANs to apply security policies associated with those. For example, if you have guests that accessing your corporate network, you can have a separate VLAN set up for guests with higher security policies that may not be applied to your IT department and other VLANs, hence increasing the security of your network. And another one would be the QoS policies. For example, VoIP traffic, we just went over. You can apply VoIP policies to that particular VLAN that is associated with the voice traffic. So those are the mostly used cases for VLANs. Ports that carry multiple VLANs on a single link are called trunk ports. You may have covered this in your previous Cisco lectures. Again, I will go through trunk and access ports in a separate short video clip that I will post to my YouTube channel later. But for now, just remember, ports that carry multiple VLANs on a single link are called trunk ports. Ports in the same VLAN that are connected to different switches can communicate with each other over the trunk link. So ports are in the same VLAN that are connected to a different switches can communicate with each other over the trunk link. Trunk ports accept and send only tagged frames with VLAN IDs, and all untagged frames are dropped, while the access ports only carry a single VLAN and accept and send only untagged frames. Typically, the end devices such as your computer have an access port, while the switches and routers may have both access ports and trunk ports. VLAN trunking protocol, also known as a VTP, is a Cisco proprietary protocol. However, is used by many other vendors such as IBM and HP switches. IEEE 802.1q, also known as .1q, is the standards that we use for VLAN IDing and VLAN configurations, and it is set by the IEEE organization. The native VLAN is associated with all untagged traffic on a trunk. So if there are a lot of untagged traffic, or if there's any untagged traffic, that would be going through the native VLANs because there are no tags associated with it. Also remember, a virtual local area network or VLAN is a way that any broadcast domain can be partitioned and isolated in smaller network at data link layer in the OSI model. Remember the data link layer from our OSI layers that we learned in the previous lecture series, the Introduction to Networks lecture series. If you don't remember, you should go ahead and watch that on my YouTube channel. So the whole point of VLAN, which is a virtual local area network, is to break up that broadcast domain at the layer 2 level of that OSI model. So that's another important concept that you should remember. Again, this slide is probably not in your notes if you're taking this class from an academic institution or through Cisco. This is a slide that I added to improve your understanding of VLAN, because it is very important you understand these concepts. Not only for this class, but also for your lab exams, as well as when you go out to the field to work with these VLAN technologies. There's a lab called Who Hears the Broadcast. It's a packet tracer file that you should have access to through your Cisco NetAcad or through your academic institution. If you do not have access to this particular lab, I will try to find a copy of this lab and post to my sanuja.com website, and I will try to go through these labs on live video demo so you have a better idea about what we just covered. And I think whenever you go through these lectures, it is very important that you also go through these labs as you study these lectures so that you have a comprehensive understanding of the topics that we cover. VLANs in a multi-switch environment. So let's define VLAN trunks. A trunk is a point-to-point link between two network devices. I briefly cover what trunk in my summary of what VLAN overview is. So Cisco trunks functions in a way that allow more than one VLAN traffic to be communicated within that trunk. It extends the VLAN across the entire network, and by default supports all VLANs and support 802.1q trunking. So what trunking can do, actually, it could allow multiple VLANs to communicate across a network. Otherwise, that would not be possible. So for example, if you have a faculty VLAN and it's communicating with faculty VLAN, but if all the student VLANs and the guest VLANs also need to be communicated across, a trunk link would allow that to happen. Network without VLANs. So if you have a network without VLANs, all devices connected to the switches will receive all unicast, multicast, and broadcast traffic. Remember, I quickly went over that information. So that piece of information is very important in understanding VLAN. So if you don't have VLANs, if somebody asks you, why should you even use VLANs, right? Because if you have a network without VLANs, all devices connected to the switches will receive unicast, multicast, and broadcast traffic. The only one that will break that broadcast domain, remember, would be a router. So unless you have a router in the middle right here, every broadcast, multicast, and unicast traffic from this side of the network will be sent to this side of the network and in between the devices. So that's what happens if you have a network without VLAN. So with network having that VLAN technology implemented, what's going to happen is the unicast, multicast, and broadcast traffic is now confined to a VLAN. So without a layer 3 device to connect the VLANs, devices in different VLANs cannot communicate. So without having a layer 3 device such as a router, the different VLANs will not receive the broadcast, unicast, and multicast messages from other VLANs. So VLAN trunks configured to support VLAN 10 and 20 only in this case. In that case, what's going to happen is those trunks going to communicate across VLAN 10 and VLAN 20 data, but no other data. So therefore, we basically isolate networks into segments using the VLAN configurations on that network. VLAN identification with a tag. The IEEE 802.1q header is 4 bytes. When the tag is created, the FCS must be recalculated. The frame checking sequence must be recalculated. When sent to the end devices, this tag must be removed and the FCS recalculated back to its original number. So in 802.1q VLAN tag field, we have the type, the user priority, the CFI or conical format identifier, and the VLAN ID, which is the VID. So the type is a 2-byte field with hexadecimal of 0xC8100. And this is referred to as the tag protocol ID or TPID. Then the user priority is a 3-bit value that it will support as assigning user priority. And the CFI is the 1-bit value that can support token ring frames on Ethernet, while the VLAN ID is a 12-bit value, which a VLAN identifier that can support up to 4096 VLANs. Native VLANs and 802.1q tagging. So in 802.1q tagging is typically done on all VLANs. Use of native VLAN was designed for legacy use, like the hub in this particular example. The hub will have a native VLAN. Unless changed, VLAN 1 is the native VLAN on most Cisco devices and many other vendor-specific devices. Both ends of the trunk link must be configured with the same native VLAN, or that trunk link not going to work. Each trunk is configured separately, so it is possible to have different native VLANs on separate trunks. So those are the key features of 802.1q VLAN tagging, and we will discuss this a little bit in further detail in next few slides. So next we're going to look at the voice VLAN tagging. The VoIP phone is a 3-port switch. So all VoIP phones, the voice over internet protocol phones, basically a 3-port switch. And the switch will use CDP to inform the phone of the voice VLAN. The phone will tag its own traffic voice, which is the traffic considered as voice, and can set cost of service, or known as COS. And the COS is QoS for layer 2. Remember that. So I have not covered cost of service in depth in this particular lecture series or my previous lecture series. For now, just remember cost of service, or COS, is the QoS for layer 2. And the phone may or may not tag frames from data that comes out of the PC. So if you have a phone connected to the same line as your personal computer, PC, the phone may or may not tag the frames that coming out of the PC because depending on how the phone is configured and how the system works. But however, what's important here is that the VoIP phone is going to be a 3-port switch. So we're going to have voice VLAN, access VLANs, like 2 access VLAN associated with it. So voice VLAN is tagged with the appropriate layer 2 class of service or COS priority value, and the access VLAN, one of the access VLAN can be tagged with the layer 2 class of service priority value, while the other access VLAN may not be tagged with no layer 2 COS priority value. I will be posting a series of lectures associated with VoIP, because VoIP is a major topic in network systems and network engineering, later on my YouTube channel. So make sure to subscribe to my channel and stay tuned, because reason for that is those lectures are coming up later this year, because it is a complete different area, and there's a lot to talk about in VoIP, and I will make sure to cover those in a separate series. For this lecture series associated with the Cisco NetAcad switching, routing and wireless essentials, you don't need to go into depth of VoIP other than to know that the QoS and OA and COS is being used in VLAN tagging for communication of VoIP data across a network. Voice VLAN verification example is shown here in this slide. So the show interface FA0/18 switch port command is used on a Cisco switch to see and check the data and voice VLANs assigned to that interface. So in this interface, it's carrying both voice data and data. So it has the voice information and the data information. So what's going to happen in here is when you enter show interface, that whatever the interface you are looking at and switch port, it's going to show you the access mode VLAN at 20 as the student, and access then you have the voice VLAN at assigned to 150 VLAN for the voice. Again, I will go through labs associated with VLAN tagging with a live demonstration that will be posted to my YouTube channel that will give you a better idea than just looking at this particular picture. There is a lab called Investigate a VLAN Implementation in your Cisco NetAcad. If you do not have access to Cisco NetAcad, or you don't have access to this lab through your academic institution, I will make sure to post a copy of this lab onto my sanuja.com website, and I will leave a link in the description. Again, it is important to go through these labs so you have a comprehensive understanding of what we have just covered. Next, we will look at how we can configure VLANs on Cisco devices. VLAN ranges on Catalyst switches. So Catalyst switches are basically Cisco switches. They are manufactured by Cisco, and Catalyst switches 2960 and 3650 support over 4,000 VLANs. That is way more than you would be needing for any of your networks. There's a table of normal range VLANs and extended range VLANs. Again, I will go into depth of normal range versus extended range later on a video, but for now just remember the Cisco Catalyst switches 2960 and 3650 supports over 4,000 VLANs, and we have normal range VLANs from 1 to 1005 and extended range VLAN from 1006 to 4095. For your exams, for this particular course, for exams and quizzes, you should know where the normal range starts and ends and where the extended range start and ends. You could get a question, a quiz question or an exam question where they will give you a random VLAN, let's say VLAN number 1050, and ask you whether it's in the normal range or extended range. So if you look at 1050, it's going to be on the extended range. If the VLAN is, let's say, 150, you know it's in the normal range. So you should be able to remember this. So make sure you know where the normal range start and ends and the extended range start and end. Again, I will go through a comprehensive coverage of what is extended, what is normal on a separate video. So the normal range VLAN, you should know, is used in small to medium sized businesses, and it typically start from 1 to 1005, and 1002 to 1005 are reserved for legacy VLANs, and as well as 1002 to 1005 are auto created and cannot be deleted. So on all Cisco devices, Catalyst switch 2960 and 3650, as well as many other Cisco devices, VLAN 1 and VLAN 1002 to 1005 are auto created and cannot be deleted and stored in the VLAN.dat file in the flash. So in Cisco switches, VLAN.dat file is responsible for saving those configuration information, and VTP can synchronize between switches. So I quickly went over what is VTP. So that information, only thing you need to remember is that, the normal range include 1 to 1005, and these are the features of that range. Then we have the extended range VLANs, which start from 1006 to 4095. They are used by service providers such as ISPs and are in running configurations of Cisco devices and switches, and support fewer VLAN features compared to the normal range VLANs, and require VTP configurations, and without them it won't be able to communicate. VLAN creation commands. So just like I mentioned at the beginning of this video, this lecture series, some of these lectures are a little bit theory heavy as well as lab heavy. So it's like 50% theory and 50% lab. So this is one of those lectures where having a lab demonstration will add value to this lecture. However, I will be doing that on a separate video, and I'll make sure to post that on my YouTube channel. So if you are working on a lab that you are creating VLANs, and the commands that you will be using are listed on the right hand side of this table. So to enter global configuration mode, as always on a Cisco switch, we go config T or configure terminal. That's a complete command, and press enter, and it will get you to configuration mode. And as I mentioned multiple times on my previous lectures, you know you are in configuration mode because you have this config in these brackets, right? So then we're going to enter VLAN, and then we're going to enter a VLAN ID. So VLAN is the command, and the VLAN ID is the valid ID number that we're going to enter. So it could be VLAN 50, for example. Then once you enter that and press enter, you will be in the configuration mode for that VLAN ID we just created. So if we enter VLAN 50 and it is not created, it's going to create that VLAN 50 on the switch, and now we are underneath it. If you already have VLAN 50 created, when you go into configuration terminal and enter VLAN 50, you will get into the VLAN 50 configuration, which is a VLAN that already on the system. So if it is not created at this point, it is going to get created. If it is already created, you're going to go into the configuration mode of that VLAN 50. Then we're going to give a name. So we can name your VLAN whatever you like. So it is a unique name to identify the VLAN, and you can enter whatever you like, and then you can go end to exit out of it. And that's how you can create a VLAN on a Cisco switch. Again, I will go through this in a live demonstration on my YouTube channel on a separate video. So here's an example of a VLAN creation. So if student PC is going to be in VLAN 20, we will create the VLAN first and then name it. So we have a student PC right here, which 172.17.20.22 IP address, and it should only be in the VLAN 20 across these switches. So if you do not name it, the Cisco IOS will give it a default name of the VLAN and the 4-digit number of the VLAN. Example, it will be like VLAN 0020 for VLAN 20. So if you don't name the VLAN, so if you just go configure T, so config T, and you enter VLAN 20 and you forgot to name it, what's going to happen is the Cisco switches will automatically name it as VLAN 0020. But you can name the VLAN by entering the command name and whatever the name you want to enter. In this case, we will be using student. It could be anything you like. It could be capitalized. It could be all simple letters. It's all up to you. You can just name the VLAN whatever the way you like. And then finally, by entering the end command, you're going to exit out of that VLAN configuration mode. VLAN port assignment commands. Once the VLAN is created on a Cisco switch, we can assign it to correct interfaces. So how you can do that is you again go into the global configuration mode with the config T command or configure terminal command. And then you're going to enter the interface command, and then we're going to select an interface. So it could be FE01 or whatever the interface. The next slide, I will show you what it looks like briefly. And then we're going to go switch port mode access, because we're going to set the port to access mode, and then switch port access VLAN, and then give the VLAN ID. And if it is the student VLAN that we just created, we're going to give the VLAN ID of that student VLAN, and we're going to exit out of it. So that's how you create a VLAN and then assign it to a specific port on your switch. Again, this will make much more sense when I go through them on a live lab demo. Just for now, just remember these are the commands we will be using. And in this assignment example, we can assign the VLAN to a port interface. And once the device is assigned the VLAN, then the end device will need the IP address information for that particular VLAN. In this case, we have that 172.17.20.22 for that student PC, and that will be assigned to that particular device, end device, so that it can communicate across this network. So in this case, we enter the configuration terminal, and we have in this example FA018, because FA018 is the port or the interface that is being used by this end device, the student PC, which we try to configure. And we're going to enter the command switch port mode access, because this is an end device and it is using the access mode to access that VLAN. And then switch port access VLAN 20. So basically we are saying this interface FA018 will be in mode access, in the access mode, and will be using VLAN 20 in that access mode to communicate. And then you're going to exit out of that, and you can save those information with copy running config startup config command. And now this switch knows that this configuration is used by this student PCs to access VLAN 20. So that's how you assigned the VLAN to a port interface so that it can use by the end device, in this case student PCs, to communicate. Again, I will go through this on a live lab demo and post to my YouTube channel. That will make so much sense to you, but instead of just reading these slides off. Data and voice VLANs. An access port may only be assigned to one data VLAN. However, it may also be assigned to one voice VLAN for when a phone and an end device are off of the same switch port. So what that basically means is, to make your physical network easier to manage, you can actually use the same port for both your VoIP desk phone as well as your computer. So to do that, what's going to happen is we're going to assign one VLAN for the voice traffic and another VLAN for your data traffic on the same switch port. So the switch port must be VLAN traffic, switch port must support, must be configured to support the VLAN traffic for both voice traffic to the phone as well as the data traffic for the PC in this case. And that can be done. It's very easy to do, and it is done by many organizations. So that way you only need one link between the desk that will be connecting the IP phone as well as the desk computer and the switch, instead of having two links or two connections, physical connections to these two devices. On my next slide, I will show you how that can be configured. So data and voice VLAN example in here. So this can be configured on a Cisco switch by entering that VLAN 20, like going into the VLAN 20, and we're going to name it as students. And we're going to give VLAN 150 and name that as voice. So we have two VLANs now created on this switch. Then what we're going to do, we're going to enter into the interface which these both devices are connected, the student computer as well as the student VoIP phone. In this case is FA0/18. So we're going to go interface or INT FA0/18. And once you are under the configuration for that interface, we're going to assign the VLAN 20, which is the VLAN that is used for data, as an access with the MLS QoS trust QoS command, and with switch port voice VLAN 150 with associated with the VoIP data. So we have the data in here and VoIP data in here. So, but they are both associated with FA/018. So newer catalyst switch will automatically create VLAN if it does not already exist when it is assigned to an interface. But the older ones, you have to make sure that you assign those VLANs to be carried out. But please note the QoS is beyond the scope of this particular course. So even though we are using MLS QoS, Trust QoS for the DHCP command, the QoS would be a separate lecture series that I will be covering on my YouTube channel that has not any association to the Cisco NetAcad switching, routing, and wireless essential lecture series. So what I'm trying to do in this lecture series for you guys to understand all the concepts you need to understand in order to get good grades on the exams and quizzes associated with the Cisco NetAcad switching, routing, and wireless essentials. So QoS is beyond that the scope of that lecture series, so I will be posting those things separately. For now, you just need to remember that you need to enter MLS QoS Trust COS on Cisco switches when you are configuring data and voice VLANs. Next, we're going to look at how you can verify the VLAN information. You can do this with the show VLAN command and associated syntax with that particular command. In here, for example, we have the show VLAN with the associated summary additional syntax associated with that, and that will give you this information. And right here we have show interface VLAN 20 that will also have some information with respect to that VLAN 20. So if you are using the show VLAN command, and here are some examples of command options that you can add to that show VLAN command, some syntax options. So we have the show VLAN brief. So you go show VLAN and then go brief. That will display the VLAN name, status, and its port 1 VLAN per line. And then if you go show VLAN ID and then you enter the IDs, for example, you go show VLAN and then we're going to go ID and then space ID number, that will result in showing some information related to the identified VLAN. If you go show VLAN, then you enter the name, syntax, and then give the name that you're looking for, the VLAN name. It will display the information about the identified VLAN name, and the VLAN name is typically is basically ASCII string from 1 to 32 characters. So basically it's a text over numbers. And the VLAN show VLAN summary. So if you enter show VLAN command and then you enter the summary option, that will display the VLAN summary information on your Cisco switches. Change VLAN port membership. So there are a number of ways to change VLAN membership. You can re-enter switch port access VLAN and then give the VLAN ID command. Use the no switch port access VLAN to replace the interface back to VLAN 1. So those are two options. So if you re-enter the switch port access VLAN and give a new VLAN ID, what's going to happen is that switch port going to change from whatever it has been assigned to the new one. Or no switch port access VLAN will remove all the VLANs associated with that switch port and put it back onto VLAN 1. Remember to use the show VLAN brief or show interface, whatever the interface you are looking at with switch port commands to verify the correct VLAN association. So on the right hand side, you can see the interface FA0/18 with no switch port access VLAN. And with that, when you go show VLAN brief, you can see what's the result of it. So what happened was to this FA0/18 interface is that it is now set back to the default VLAN, which is the VLAN 1, because we have entered the command no switch port access VLAN, because that will result in setting that interface back onto the default VLAN, which is VLAN 1. But if you also enter the show interface FA0/18 switch port, that will give you the information related to that switch port and what mode that VLAN is in, because now we have removed any VLAN association. You can see with this summary briefing, summary information briefing, that it is on VLAN 1. So this confirms that the FA0/18 is now associated with VLAN 1. So again, it is kind of confusing to just go through this through slides. So what I'm going to do, I'm going to post a video with the lab example so that you'll have a better understanding of how this exactly works. Delete VLANs. So you can delete VLANs with no VLAN command. So what you need to do actually is to enter no VLAN command with the VLAN ID that you would like to delete. That will completely get rid of that VLAN ID from your switch, your Cisco switch. But however, we would recommend that before you deleting any VLANs, you reassign all member ports of that VLAN to a different VLAN, so that you are not going to get any service issues on your network. Delete all VLANs with the delete flash VLAN.dat or delete VLAN.dat commands. That will delete all the VLANs in the switch, and you need to reload the switch when you are deleting all VLANs. So if you go no VLAN and if you give the VLAN ID, you're going to only delete that one particular VLAN. But if you want to delete all VLANs, what you can do, actually you can delete VLANs from the flash of your Cisco switch or router, and this is how you do it. Please note, to restore to factory default, unplug all data cables, erase the startup configuration and delete the VLAN.dat file, then reload the device. So if you want to set your Cisco device to factory settings like a Cisco switch, what you need to do is to unplug all data cables, so there is no state up there, and then erase all the startup configuration and delete the VLAN.dat file, and then reload the device. Otherwise, it may have some VLAN data associated from previous configurations still in the switch or router. There is a packet tracer activity called VLAN configuration. If you have access to Cisco NetAcad or you have access to this file through your academic institution, please go ahead and do this lab. If you do not have this packet tracer lab available to you, I will try to find this packet tracer activity and post into my sanuja.com website so you can download it and go ahead and do them. I would recommend that you go through these activities as you go through this lecture. VLAN Trunks. Trunk configuration commands. So in this page, they summarize some of the most used trunk configuration commands. And these are the commands that I use basically to configure trunks on switches and routers as well. So configure and verify VLAN trunks. Trunks are layer 2 and carry traffic for all VLANs. So remember that the trunks are layer 2 type, and then it can carry traffic for all VLANs. I describe the difference between a trunk and access ports and a whole bunch of things at the beginning of this lecture. Yeah, you can go back in this video and check it out, those summaries. So if you want to configure a trunk on a Cisco switch, what you do, actually you get into configuration mode by config T or configure terminal, just like previously when we tried to configure switches. And then in the configuration mode, we're going to go interface and we're going to get the interface ID, and then we're going to go switch port mode trunk. So switch port mode trunk. So that's where we're going to make it trunk port, and we're going to make switch port trunk native VLAN, and then we're going to give the native VLAN ID that we're going to be associating with that trunk. Then switch port trunk allowed VLAN will give you a list of VLANs you can enter. that will specify the list of VLAN that will be allowed in that trunk link. So these are multiple VLANs you can enter right here out after this. So you go switch port trunk allowed VLAN, and you can enter the list of VLANs that you can allow through this trunk. Then finally you can exit out of the configuration mode by setting the end command. But remember, don't forget to save your running configuration after you do any changes to your switches and everything seems to be working. You need to make sure that you need to give copy running config startup config. That will make sure that you save all of these commands. Again, I will go through these in my lab videos. Just for now, remember, this is how you configure trunk in VLANs. Trunk configuration examples. So here Cisco is giving us a very good graphical representation of a network. We have faculty on VLAN 10, student on VLAN 20, and a guest on VLAN 30, and they have separate IP addresses and also subnet mask, separate subnets associated with it. So that's how we have 10.21, 20.22, and 30.23. And they are all connected to a single switch here, S2, and that S2 is connected to S1. Now we have that information display right here, and F01 port on switch 1 is configured as a trunk port. So F01 that is connected to the F01 of the switch 1. So F01 of the switch 2 is connected to F01 of the switch 1, and this link, these two switches connecting with this link is a trunk link, and that trunk link is configured with interface FA01, switch port mode trunk, switch port trunk native VLAN 99. So the native VLAN is set to 99, and switch port trunk allowed VLAN 10, 20, 30, 99. That means they are allowing 10, 20, 30 plus the native VLAN, which is 99. So in this example, this assumes a 2960 switch using 802.1q tagging is used. Layer 3 switches require the encapsulation to be configured before the trunk mode. So remember that. So that's what they are trying to get here in this page. And one thing I would like to point out is that if you have bunch of VLANs that goes from, let's say, 10, 11, 12, 13, 14, 15, for example, you can go switch port trunk allowed VLAN 10 dash then 15. I believe you can do that. I will test that out and post it on my YouTube channel when I do the lab. This is basically by putting a comma. What we are doing is we individually assign, telling these are the assigned VLAN that is allowed in this trunk. So in this case 10, 20, 30, and 99. Verify trunk configuration. Set the trunk mode and native VLAN. Since sh int fa0/1 switch port command will display the information we need to verify the configurations, because that will tell you whether the trunk is set administratively, whether the trunk has operationally working, that means functioning. Encapsulation type, it will tell you the information about native VLAN and all the VLANs associated with that trunk. That trunk, in other words, like all the VLANs that this trunk will allow for traffic to pass through. So in here, sh int fa0/switch port is the same as show interface fa0/switch port. This is the long form. Again, as you go through these Cisco lectures, as you become more familiar with Cisco switches and routers, you'll get to learn a lot of shortcuts. Instead of typing this whole show interface fa0/1 switch port, you can go sh int fa0/1, and even you don't even need to type switch port. You can do I believe SW and then press enter, and that will give you the same thing. So in this diagram, this screenshot on the right hand side, Cisco is exactly showing how you can verify the trunk configuration. Again, I'm not going to go into too much detail on this because I will be doing this on one of my lab demonstration. Just remember this command and what is it used for in your labs. Reset the trunk to default state. So what happens if you set up a trunk and you realize that, I made a mistake, I would like to set everything back to the default state? Well, you can do that to reset the default trunk setting with the no command. So all VLANs allowed to pass traffic and the native VLAN will be set to 1. So verify the default setting with the shint, again the same thing. So in this case, if you have the interface FA01, you're going to go into the interface configuration mode by typing int FA01 or interface FA01 by press enter and type no at the front of the switchboard trunk allowed VLAN and no at the front of switchboard trunk native VLAN, and that will delete whatever you have entered and reset the trunk to the default state. So that's all you need to know. And then when you go show interface FA01 or whatever the switchboard that you perform this operation, you will see that you have the switchboard set to the default and the trunking VLANs is enabled set to the all, right? So that's what the deleting of or resetting the trunk back to default state would do. Resetting the trunk to the access mode can be done with switchboard mode access command. So what's going to happen is it will reset the trunk to an access mode instead of the trunk mode, and it is set to an access interface administratively and is set as an access interface operationally. So it will be like administrative and operational will be access mode when you enter the switchboard mode access. So as I mentioned in my past lectures and videos, basically administrative access, administrative state mean basically you tell the switchboard to act in a certain way administratively. It become operational when you plug in a device with that, like for example, end device with the access mode, and that's going to result in functionally, operationally becoming an access port. So only thing you need to do that is to enter switchboard mode access in that interface. So for example, you go into interface FA01 in this example, and we're going to enter the command switchboard mode access and press enter. And when you exit out of that and you go show interface FA01 switchboard, which is this switchboard, it will show you that the administrative mode is sent to static access and the operational mode is also in static access as well. So that's what this command is doing, is it is resetting the trunk to a default state of the default state and putting them into the access mode by this command. Again, there is a packet tracer file called configure trunks. If you have access to Cisco NetAcad modules, please go ahead and download this packet tracer file from your Cisco NetAcad and please do them. Or you may be able to get hold of this file from your academic institution. If you do not have access to this packet tracer file, I may be able to get a copy of that. And if I find that one, I will post it on my website. There's also a lab activity called configure VLANs and trunks. Again, if you have access to these files, please go ahead and do them. If you do not, I will try to get hold of them and post it to my website, because it covers most of the items, if not all of the items that we have covered in this lecture. So by doing these labs and activities, you will get a more comprehensive understanding about topics that we have covered. Dynamic Trunking Protocol, or DTP. So here's an introduction to DTP, or Dynamic Trunking Protocol. It is a proprietary Cisco protocol. DTP characteristics includes on by default. There are, DTP is turned on by default on Catalyst 2960 and 2950 switches. Dynamic auto is default on 2960 and 2950 switches. Maybe turn off with the no negotiate command. So they can be turn off with the no negotiate command. Maybe turn back on by setting the interface to dynamic auto. So if you set that interface to a dynamic auto, the DTP automatically going to be turned on. Setting a switch to a static trunk or static access will avoid negotiation issues with the switch port mode trunk or the switch port mode access command. So remember that setting a switch to a static trunk or static access will avoid negotiation issues with the switch port mode trunk or switch port mode access commands. So that's what they are trying to show you on the bottom of the screen. So you have switch port mode trunk and switch port set to auto no negotiate, and what that will do is that it'll turn off the DTP, right? So remember that. Negotiated interface modes. The switch port mode command has additional options. So you can use the switch port negotiate interface configuration command to stop DTP negotiation. So the options associated with the switch port mode include the access, dynamic auto, dynamic desirable, and trunk. So you just need to know what they do, like for your labs. I have seen some lecture exam questions come up with it, but mostly lab exam questions. So you need to know how these configuration commands work and what are these options means. So it's pretty simple. So if you put it into access, it will put the permanent access mode and negotiates to convert the neighboring link into into an access link. Just like the option name suggests, dynamic auto will become a trunk interface if the neighboring interface is set to trunk or desirable mode. Dynamic desirable, what's going to happen is actively seek to become a trunk by negotiating with the other auto or desirable interfaces. So it will give priority to try to set it as a trunk. And the trunk mode will permanent trunking mode and negotiates to convert the neighboring link into a trunk link because it's in the trunk mode. So you should know what these options are and how they are differ from each other. Results of a DTP configuration. So DTP configuration options can be summarized in this particular, this table. I'm not going to go through all of them, but you can pause this video and make sure that you understand what they means. For example, dynamic auto and how the DTP configuration options should be set up. Versus how dynamic disable, trunk, and access should be set up. Again, I will go through in much more detail in my lab demonstration that I will be posting to my YouTube channel later. Verify DTP mode. So just like we have verified the previous VLANs and all the other configurations, you can also verify the DTP mode, and you should be verifying those configurations whenever you are making changes to Cisco switches on your network. So the default DTP configuration is dependent on the Cisco iOS version and the platform. Older version of Cisco devices may have a different Cisco iOS and may behave differently. So use the show DTP interface command to determine the current DTP mode. The best practice recommends that the interfaces be set to access or trunk and to turn off DTP. So it is highly recommended that the interfaces be set to access or trunk mode and you turn off the DTP. There are a couple of reasons for this. One of them is the overhead. It will reduce the overhead on your network. But for now, you don't need to know any in-depth information associated with why we recommend this. But you should know that it is a best practice to turn off the DTP. But at the same time, you also need to remember to set the interfaces either to access or trunk mode, right? So otherwise, your system may not work the way you are trying to get it to work. Again, there's a packet tracer file called configure.dtp. If you have access to that file, please go ahead and download it from your Cisco NetAcad or through your academic institution and do them, because that will give you a overview of the things that we have covered, such as the configuring static trunking and configure and verify DTP. And that would bring us to the end of this lecture. And I will go through the summary of it. So before we do that, there is another packet tracer file called implement VLANs and trunking. If you have access to those files, go ahead and do them. If you do not, I will try to find those ones and post it to my website. And same goes for the lab, implement VLANs and trunking. If I find them, I will post into my website. If you do have access to them, please go ahead and do them. So what we have covered in this lecture is that we learned that the VLANs are based on logical instead of physical connections. So VLANs are virtual. V stand for virtual. So VLANs are based on logical instead of physical connections. VLANs can segment networks based on function, team, or application. Remember, VLANs can segment broadcast domain. So remember those concepts. Each VLAN is considered a separate logical network. A trunk is a point-to-point link that creates more than one VLAN. VLAN tag fields include the type, user priority, CFI, and VID. A separate voice VLAN is required to support VoIP or Voice over Internet Protocol. Again, I'm going to do a completely separate lecture series on VoIP. So, we didn't go into depth how important VLANs for VoIP in this course, but you should know it is a key feature in properly operational VoIP system, the VLANs. Normal range VLAN configurations are stored in VLAN.dat file in Cisco Flash, in Cisco devices. An access port can belong to one data VLAN at a time, but may also have a voice VLAN. So you can have an access port with one data VLAN, but also can be associated with a voice VLAN. We also learn a trunk is a layer 2 link between two switches that carries traffic for all VLANs. Remember that concept of 802.1q. So we learned that the trunk will need tagging for various VLANs, and they are typically using that IEEE 802.1q tagging, which makes provisions for one native VLAN that will remain untagged. An interface can be set to trunking or non-trunking. So it is a configuration option available on Cisco switches. Trunk negotiation is managed by DTP or Dynamic Trunking Protocol. However, we recommend that you turning off the DTP and setting your trunk or access VLANs. DTP is a Cisco proprietary protocol that manages trunk negotiation. So you should know all of this concept at the end of this lecture. And that's everything for today. If you like these type of lectures, please thumbs up this video and subscribe to my channel. If you have any questions or concerns with respect to this lecture, please feel free to reach out to me. Until next time, good luck with your exams and have a nice day.